Okay, we're going to start off this year in science looking at Earth as a system. So this is going to be some of the first topics that we will be looking at this school year. And we started off the year and we talked about what Earth is, and we have this picture of Earth. And we came up with a lot of different things that make up the Earth when we did our class discussions. Things like the atmosphere, and the ground, and the people on the planet, and the clouds and the water, the oceans. And we decided we can break that up into a lot of different segments and look at those individual segments. So as we take a new view of the Earth, we're going to look at Earth Science System as a collection of parts. And then we want to take those parts and see how they are interconnected or how they fit together. We had a nice discussion about technology, and we looked at the 50 greatest inventions according to the Atlantic magazine, and especially focusing on the top 10. And one of the main reasons we looked at that is we could see how these inventions changed the Earth, and some of them on how we study the Earth, and how some of those things affected the way we look at the Earth. We make a lot of models, and we kind of try to make representations of processes or events that happen on the Earth. We can look at the globe as an example of a model, or the water cycle or the carbon cycle as examples of models. We look at systems within models, and we look at two kinds of systems. We look at closed systems, and we talked about closed jar or a closed car, and we looked at how the matter inside that closed system does not move freely. Okay, it stays within that system. Similar to the way the Earth is a closed system, we're not getting any more materials really added to the Earth, and we're not really giving off any materials to outer space. However, we are getting an exchange of energy. We give off energy to outer space, and we get energy from the sun. So energy can move around freely, but matter cannot. One of the things I use as an example is water. It's the same water on the Earth from a billion years ago or more that we're using today. It's the same water that T-Rex used, and the dinosaurs, and George Washington, and it's the same water coming out of our tap. It just keeps getting recycled in different parts of the Earth. And we compare that system to an open system. And with an open system, we're able to get matter to move freely. So we're looking at the car with the windows or the doors open, and you can get in and out of the car. Energy can freely move, and matter can freely move in and out of that system. We talked about Earth again, and I mentioned that before, being a closed system. It's not a perfectly closed system. We do give off a little bit of matter in terms of our atmosphere to outer space. Every now and then we lose some particles. And we do get meteors coming into Earth and burning up, and they would give some matter back to Earth, but overall the mass remains constant. And we kind of talked about, is it a good system or a bad system, and we kind of said that it's a pretty good system. Otherwise life would not be able to exist on the planet. Are there rooms for improvement, or could there be things that would change that might make things better or worse? Absolutely. But overall it's a pretty good system. And I have there, some explanation as to why we're not going to be able to get new resources. So when we use up a lot of the resources that we have on the planet, they are completely gone. We're not going to get any more. And I have there an effective system. That's why life can survive on Earth. Okay, so we're going to break the Earth down into 4 segments: atmosphere, hydrosphere, Biosphere, Geosphere. Okay, and we had a little discussion about how these spheres can interact with each other, a lot of them being natural disaster or storms, or things like pollution affecting some of the other areas. But again, when we look at the atmosphere, that's the sky and the air. When we look at the biosphere, we're talking about living things. When we look at the hydrosphere, we're talking about rivers, lakes, and water. And oceans. When we talk about geosphere, we're talking about the physical surface of the Earth, just not the water. Okay, when we look at these four spheres again, this little diagram, I had a lot of you guys copy this down, especially the left-hand side of the diagram, knowing that just that the Earth is broken up into these four main parts, that the atmosphere and the sky are kind of one area. The biosphere are the living things, the plants and the animals. The geosphere is the surface of the Earth, the rocks, the dirt, and the dust. The hydrosphere, again, is the lakes and the rivers and the groundwater would all be part of that hydrosphere. Then we started to talk about these different spheres. We got into the atmosphere, which is composed of gases, some of them being oxygen and carbon dioxide. I have here that most of the atmosphere is made up of nitrogen, and the second most abundant gas, oxygen, and then argon. Things like water vapor and carbon dioxide are in that less than 1%, and argon is the most common one. We have trace amounts of gases, things like carbon dioxide and oxygen. Some of these gases are going to absorb or alter rays of the sun, and we talked about this in class, where we have things like the ozone layer. 3 molecules of oxygen combined together that block out ultraviolet rays from the sun and protect us from a lot of things, or kind of lessen the effects of the ultraviolet rays of the sun, so we don't get as much things like skin cancer. Other things that affect the rays from the sun, gases like carbon dioxide and water vapor absorb a lot of the energy from the sun, a lot of the heat. Things like nitrogen and oxygen let that heat just pass right through and then kind of re-radiate off the surface, where gases like carbon dioxide and water vapor will absorb that heat from the sun, that energy from the sun, and then warm up the other air molecules. So it's very, very important that we watch the amount of carbon dioxide we let into the atmosphere because of that reason. Storms occur in the atmosphere. Okay. We talked about Earth being the only planet that could harness life. We're the only planet in our solar system with liquid water at its surface. I mean, we can look at some of the moons of other planets, and we can look at Mars at one time, maybe having liquid water on its surface. But right now, because Earth has liquid water on its surface, we feel that that's one of the key components for life. It's not so much the gases that make up our atmosphere, but it is the liquid water on our surface. And the thick blanket of atmosphere is a big reason why we're able to have that liquid water on our surface. When we look at the layers of the atmosphere, all life exists in that troposphere, that bottom layer of the atmosphere. So we have our bottom layer of the atmosphere, the troposphere. Then we get into the stratosphere with the jet stream and some different areas there. The mesosphere, that's where a lot of the quote-unquote shooting stars burn up, or the meteors burn up as they come into the Earth. And then we get into our transition point above the mesosphere into outer space. We have our thermosphere and our exosphere of varying thicknesses. And then we have here auroras, things that get produced by Earth's magnetic field. And as the gases in this part of the atmosphere get excited, they glow in different colors. Those harmful particles from the sun interact with that magnetic field and cause the atmosphere to glow. Then we got into the geosphere, the Earth itself, the rocks, mountains, beaches, and other physical parts, just not the water. We talked about how the geosphere can change through natural disasters, things like volcanoes and earthquakes, where the surface of the Earth, while it seems solid, again, we get into a little bit of the plate tectonic theory and this idea of the Earth being a jigsaw puzzle at the surface and interconnected pieces. And a very, very quick diagram talking about continental drift and the plate tectonics moving. Volcanoes are kind of these rising plumes of magma from inside the Earth that then make it up to the surface. From there, we went on and we looked at the hydrosphere. We talked about all of the water on Earth, the lakes, the oceans, and the groundwater. Snow and ice are also part of that. And as we kept on talking about that, 97% of the water that's on Earth is salt water, and only 3% of that water is fresh. And out of that 3% of fresh water, most of that is locked up in ice caps and glaciers. Actually, a little over 2% is locked up in ice caps and glaciers. leaving less than 1% of the water as fresh water, and we only use about 0.5% of that for drinking water. So we use a very, very small amount of the water on Earth for human consumption in terms of water to brush your teeth, take a shower with, and be able to drink. We also watched the video Tapped. With the video Tapped, we had the worksheet that went along with it. We talked about the problems with drinking water and bottled water and what bottled water companies actually do. We had some of the questions on here and how some of the plastics that they use are not very healthy for us. We went over these questions after we watched the video. We kind of talked about that. We got into a little discussion about the FDA and what they allow in different foods, and how they monitor the sale of water bottles, and what water bottle companies do, how they test their waters, if they test their waters at all. So we did a little bit of work on that as well. Okay, and we have a picture here of the water cycle. We look at precipitation, bringing water out of the atmosphere back down to the surface. That water goes into lakes, rivers, streams, possibly the ocean, and then it will evaporate back up. And the process starts over. Along the way, water can change into snow and ice and different forms on the surface of the Earth as well. We just talked about that. Then the biosphere. We don't really spend a lot of time on the biosphere in this class, only because we're not a biology class. So we just kind of mentioned that the biosphere are the living things, the plants and animals. And we are going to stop there, and I'm going to make a separate video for the rest of class.